Boys and girls, this is Mr. Manise here again with another super cool video, and in this video I'm going to teach you guys how to transform quadratics on the coordinate grid. So we are in our coordinate geometry unit, and this is the second thing that we're going to learn about. We previously learned about circles and equations of circles, so we're moving on to quadratics. Just a little side note, I'm making this video in March of 2020, and we are starting our first ever uncharted learning from home as the coronavirus is taking the world by storm. So if I'm still teaching in 20 years and we look back at this video, you can say, wow, this video is being made right as the coronavirus was taking the world by the throat. So hopefully they will come up with a cure and a vaccine, and we will be done with this and we will get back to normal life as we know it. So let's go ahead and jump in to this lesson, transforming quadratics. So it says transforming quadratic functions works just like transforming any other function. Okay, you guys have learned about turning, flipping, rotating. It says, however, to be a bit more specific with quadratics, we'll spend more time looking at the vertex form. First, a quick review of the general function notation transformations. So if I have any kind of function, it doesn't have to be a quadratic, it could be a line, it could be a cubic, a quartic, or whatever. It says in general, we have talked about translating functions up or down, translating functions left or right, and stretching functions away or closer to the axes. Here's a quick review. So if I have a regular function, if I have some function and I add some constant to it, then we're going to be translating up and down. So I'm going to use the analogy of a quadratic since that's what we're talking about in the lesson. So for example, I'll give you a couple of examples. Let's say that I have our normal parent function for a quadratic. You guys learned this last semester. Y equals x squared. Okay, it's a quadratic because the highest exponent is a 2. Okay, so that's a regular quadratic. Now if I take that quadratic and I add some constant to it, let's take that guy and let's add a 6 to it. Okay, what did I just do? I took my parabola, every quadratic forms a parabola on the coordinate grid, and I shifted that guy up. So I take everything that I've got on my grid and I just move it up 6 spots. Okay, so if C is positive, then we're going to say that the function is shifted up. Okay, on the flip side of that, of course, if C is negative, the function is shifted down. So that would be something like y equals 3x squared minus 4 or something like that. Okay, it doesn't even matter that there's a coefficient in front of this x squared. I'm just taking some function, I'm adding a constant to it. Okay, now that's your translation up or down. Well, what happens if I'm moving it left or right? That's when I have a function, but the constant is added inside this parentheses piece. Okay, so once again, if we're talking about a quadratic, I'm going to have something like, for example, y equals parentheses x plus 4 squared. Okay, so notice the difference. Over here, we don't have any parentheses, and over here, I do have parentheses. And again, this could be for a cubic, a quartic, or whatever. Okay, so I've got x plus 4 squared. And this says if C is positive, the function is actually going to be shifted. Which way do you think? Shifted to the right because it's plus 4? I need my bell. It's actually going to be shifted to the left. Okay, I'll explain that in just a second. Why is it shifted to the left? Okay, so another example would be something like this. Y equals parentheses x minus 3 quantity squared. Okay, if C is negative, so this guy inside the parentheses is negative, then of course it's going to be shifted to the right. Okay, now hold up. Now, why is it backwards? Okay, the reason why it's backwards is because if we look at, for quadratics, if we look at this form here, we got transforming f of x equals a times x minus h squared plus k. This guy right here, that is your vertex form. Now remember, f of x just means function. Okay, so that could be f of x equals y equals, they all mean the same thing. So put that in your notes. This is vertex form for a quadratic. Okay, now why is it called vertex form? Because when I'm in this form, I can immediately tell you what the vertex is. Just like we learned about a day or two ago with circles, if I want to know what the center of my circle is, then what do we do? So let me get a blank piece of paper here just real quick. So with circles, we had something like x minus 4 squared plus y plus 3 squared equals say 36, okay? To get the center, what did I have to do with those signs? I had to flip those, right? So my center would be 4 comma flip, 4 comma -3, and of course the radius would be the square root of 36, which is r. Okay, that was the previous couple of lessons, but we had to flip these signs. If I'm in vertex form of my quadratic, it's going to be y equals a times x minus h squared plus k. Well, my center is actually going to be h comma k. All right, I don't want negative h, negative k. I want the center, which is h comma k. The center of my circle is, whatever. Okay, so for circles, its center equals h comma k. Let me write this down. That's for circles. Okay, for quadratics, I don't want the center. I don't have a center. I've got a vertex. So the actual vertex in this case is also going to be h comma k. And that's going to be a very common theme, guys, especially when you get to advanced algebra next year and you talk about logarithms and all this kind of fun stuff. That's going to be a similar concept there, okay? But if I go back up to my equation, it's x minus h. Okay, so if I need h comma k, what am I going to have to do with this in the parentheses piece? I had to flip the signs here. I got to do the same thing. I got to flip the signs here. Now notice the k though is not in parentheses. So I will not flip the k value, but I will flip the h value. And let me show you why. So let's say that we're plotting a parabola, and let's say that we have a quadratic, something like 2 times x minus 3 squared plus 4. Okay. So if you guys remember, the vertex is always going to be the highest or lowest spot of your graph, right? I've got a parabola, it's going to look like this, or it's going to look like this. It's going to be a right side up U or an upside down U, okay? So the vertex in this case is I got to flip that guy. So my vertex is actually going to be positive 3, comma, positive 4. I'm going to flip that guy, I'm going to leave that guy alone because my center is h comma k, but in my equation, vertex form for a quadratic is x minus h. Okay, and why is that? Well, if I were to plot this 3 comma 4, I've got 1 2 3 1 2 3 4. So 3 comma 4, that's going to be my vertex. My graph is going to open up, which is the point of this lesson. The graph is going to open up because there's no negative here. I don't have a reflection. I'll talk about that in just a bit. So my parabola is going to look something like this. So my vertex is always going to be the maximum or the lowest spot of the graph. Okay, well, if you think about this piece right here, if I take x and I add a number or subtract a number and square it, what's going to happen? It's always going to be a positive number, right? So this guy right here, that guy is always going to be positive. Okay, so if I want to find the lowest spot of my graph, then this piece needs to equal what? It needs to equal 0, right? Okay, so I've got to figure out, because I'm going to take this guy, whatever it is, I'm going to take some number, whether it's negative or positive, I'm going to square it, and I'm going to add it to 4. Okay, so when I get the lowest spot, that means this whole guy has to be 0. To get the lowest spot, I don't want to add anything to 0, because if this number is 1, or if it's 5, then it's going to be higher than that. This piece is always going to be, x is always going to be greater than or equal to 0, because when I square negative or square positive, I always get at least 0, some positive number. So I got to figure out what is it going to take for this guy, this piece of the vertex form to equal 0. And that's simply going to happen when this guy right there is going to be equal to 0. Okay, so I need to set that equal to 0. X minus 3 equals 0, and obviously x equals 3. So if I want to find this low spot, the vertex of my graph, I've got to use this value. That's why my vertex is 3 comma 4, and that's why I have to flip this sign. Okay, so if any part of that was confusing, pause the video, go back and rewind those last couple of minutes. So that's just kind of a visual why I've got to flip that guy. Okay, so let's go back to our notes here. Okay, so when I'm in vertex form, the center, write this in your notes, your center is going to be h comma k. All right, so it says, let's talk specifically about transforming quadratics in vertex form. Since the point h comma k is the vertex, those values give us our shift left, our shift right, and our shift up or down. It says, consider the parent function f of x equals x squared. Then the function g of x equals x minus 4 squared minus 7. If I were to flip that sign and leave that guy alone, my center would be what? It would be 4 comma negative 7, right? So if I have a center of 4, negative 7, that means it's being translated 4 to the right, okay, because that's my x value. I'm going 4 to the right. And then what am I doing with the y? It's negative 7, so I'm going down 7. Okay, so 4 to the right and 7 down because the vertex is 4, negative 7. So this is a little diagram here that's going to kind of illustrate what we just said. This is our parent function f of x. Okay, I have no h, I have no k. So my center is 0, 0. So the center is the origin. Okay, I'm going to take this parent function and then I'm going to transform it. I'm going to put x minus 4 in the parentheses squared piece, and then I'm going to subtract 7. Okay, so I don't know if you guys can see this different color. This is the original black graph, and this is the blue graph, and it's showing you that I actually have a transformation of going right 4, down 7. If you don't believe me, plug it into your graph. So I'm going to type in y equals, type in parentheses x minus 4 parentheses squared minus 7. I'm going to graph that. Now, if your graph looks all wacky, if it doesn't look like this, I'll show you a little trick. Press zoom where my finger is, press zoom, and then press option 6. Okay, zoom standard will always get you back to your standard window. If you wanted to change your window, you could go to window, you could do this manually. Your window just says, okay, Mr. Moniz, how far to the left and how far to the right, how far up and down do you want me to go on the axes? I want the lowest x to be negative 10. I want the highest x to be 10. I want the lowest y to be negative 10. I want the y to be 10. So if I go to graph, this is your standard graph where each unit is worth 1. I'm going up to 10 and down to 10 on the y, left to 10 and right to 10 for the x. So you can see here from our graph, we've taken our parent function and we shifted it 4 to the right and down 7. Vertex is 4 comma negative 7. Okay. Now, let's move along here. So in the next piece, it says the A value in the vertex form is a little bit different. It says sometimes that is called the stretch value. Okay, let's think about why. All right, if A is greater than 1, then the transformed function output will be higher than the parent function. Since a parabola is U-shaped, this will mean the parabola will narrow as it goes up faster on both sides of the vertex. Okay, so let me give you guys, grab a rubber band here. This is what I use when I normally teach this lesson. Okay, so the best way I can explain what I just read to you is think about the parabola as a rubber band. Okay, so this is my U shape. All right, if this A value that they're talking about, if the A value, now what is the A value? Here's my A value. The coefficient in front of the parentheses squared piece is my A value. Just like we have y in our standard form of a quadratic, ax squared plus bx plus c, there's my A value, okay? So that's called the stretch or the shrink factor. In vertex form, it's right out front. So if I take a normal quadratic that doesn't have a stretch or a shrink, if I throw a number in there that's greater than 1, okay, greater than 1, then I'm going to be stretching my rubber band. So here's the parabola. If I put a 2 in front of it, I'm stretching the rubber band. If I put a 4 in front of it, I'm stretching the rubber band. And then what happens is that A value goes up and up and up. That rubber band's getting longer and skinnier, right? Okay, I'm stretching the rubber band. That's what's called a stretch factor. Okay, so really and truly what I need you guys to understand, make sure you make a mental note of this, is the absolute value of the A value is really all we care about, okay? Because if that value is positive or negative, I don't care about the negative. It's just that it's just the numerical value, the absolute value. If this were a -2, a lot of students will make this mistake and say, oh, it's being shrunk because it's less than 1, okay? The negative just means it's a reflection. So I'm just looking at that number to say whether or not it's a stretch, okay? All right, if it's less than 1, if it's some fraction between 0 and 1, like 0.3, 1/2, or something like that, that's where we get an actual shrink, okay? So let's take a look at an example here. All right, so it says the original function, I have x plus 5 squared minus 9. The vertex is -5, -9 over here. And then I'm going to transform that. I'm going to throw this 3 in front of it. Okay, so you'll notice here this is the original black graph, and then I've got the blue graph, and notice that the parabola narrows, okay, or it's being stretched like a rubber band. Okay, so let me illustrate that on the graph. So let's take this. I'm going to do the original, x plus 5 squared minus 9. Okay, I'm going to plot that graph. Okay, there's the original. Now I'm going to go back. I'm going to keep that there, but I'm going to throw a 3 in front. 3x plus 5 squared minus 9. Okay, now watch what happens. All right, that's just what it was showing there on the paper. I just wanted you guys to visualize on the calculators, getting narrower. Okay. All right, so let's go ahead and flip on over to the next page. Okay, so that's what happens when you have an a value that the absolute value is greater than 1. I'm actually going to skip this part. I'm going to come back to it while we're on the issue of rubber bands stretching and shrinking. I'm going to skip on down to this. And this says if a is between 0 and 1, which I was just telling you guys, then the transform function output will be smaller than the parent function. Okay? Since a parabola is U-shaped, this will mean the parabola gets wider as it goes up slower on both sides of the vertex. Okay? So here is an example. So I'll go back and clear this out of my calculator. So I have this quadratic, x squared minus 5. Okay? And then I'm going to transform it. I'm going to throw a value in front of the x that is between 0 and 1. Okay, so I'm going to do 0.1. I could do 1/10. That's the same thing as 0.1. 0.1 x squared minus 5. Okay, and then let's graph that. So here comes my original. Okay, and here comes my new parabola. Notice that it kind of opens up. I'll teach it like it kind of opens up as a flower, like a tulip, if you want to think of it that way. So the flower opens up, it shrinks, it flattens. Okay, so that's what happens when you throw a number in front that is between 0 and 1. Okay, parabola widens. Now let's go back up here and let's talk about the big mistake students make in this lesson, and that is when there is a negative in front. It says if the a is negative, then the transform function output will be reflected across the horizontal line through the vertex. In other words, it will flip upside down. Okay, and you guys have seen this before with lines. You guys did this in coordinate algebra. Now we're going to be doing it with quadratics. Guess what? Next year you'll be doing it with cubics and quartics. Okay, so same kind of concept. If I take my original function, f of x equals x plus 2 squared plus 4, my vertex is what? Flip that sign, leave that guy alone. Negative 2 comma 4. So negative 2 comma 4. And I'm going to transform it. I'm going to keep everything the same. I'm just going to throw a negative in front. Okay, so this is showing you here, this is the original black line, and this is the reflected parabola in blue. I'm flipping it upside down. Flippy flip, as I like to say. So I'll show you guys that. So we've got x plus 2 quantity squared plus 4. And then I'm going to throw a negative in front. Now, when you do this on the calculator, guys, don't press that minus button. If you press minus, your calculator is going to explode. You got to press the negative button. Negative x plus 2 squared plus 4. All right, I'm going to graph that, and you'll see there's a regular, and then it flips upside down. So this parabola opens down. So the main thing you need to understand from this is that when you see that negative, guys, it's a flip. It's a horizontal flip. Most of the times I just say y-axis reflection. Technically, you're not reflecting over the y. You're always reflecting over this horizontal line where the y is. Okay, so in this case, my vertex is actually negative 2 comma 4. Sorry, negative 2 comma 4. So I'm flipping over that guy, which is y equals 4. I'm flipping over the horizontal line wherever the y coordinate of the vertex is. So in this case, I'm flipping over this line, y equals 4. Okay, but I just say y-axis reflection. You're reflecting up and down, okay, as we flippy flip. Now, again, the big mistake here, guys, is that people will think that that negative means it could be a shrink. So, for example, let's say that I had y equals negative 3 times x plus 4 squared plus 5. Students will make the mistake and say, oh, that's less than 1. That must mean that it is a shrink. That is not true. For the stretch and the shrink, guys, I'm only looking at that guy right there. Let me prove it to you. So when I type in the example that I just created, I've got negative 3 x plus 4 squared plus 5. okay, you'll notice that this is still a skinny graph, okay? So that's why it's still a stretch. So the negative just means it's a reflection. That's all that means. So I've got a reflection, I've got a stretch, my vertex is -4, and my -4, 5. So let's go ahead and jump into some problems here, and you'll do a few of these and you'll catch up very, very quickly. You'll catch on. So the way I'm going to do this in this lesson, guys, I'll work a few of these for you, and then what I want you to do is the ones that I don't do in the video, I want you guys to finish those for your assignment for your homework. Okay, so it says identify the vertex and describe the transformations from the parent graph and then sketch the graph. Okay, so here's how you do this. There are four different types of transformations that you can have. And I always do this, guys, and read the book from left to right. The first thing that you could possibly have way out in front when you're in vertex form is that negative. I want to check and see, do I have a negative out front? Yes or no. If I don't, then the graph opens like a normal U. The graph opens like this. If I have a negative, that means the graph opens down. Okay. If I don't have a negative, the next thing I look for is that A value. Do I have a number in front of the parentheses? If the absolute value is greater than 0, if the absolute value is greater than 1, then it's a stretch. If it's between 0 and 1, then it's a shrink. All right, so in this case, I don't have either. I don't have a reflection, I don't have a stretch or a shrink, and now I just look to see basically what is my vertex. Okay, so what I'll have you guys write down in your notes is the vertex is going to be what? Flip that sign, flip that, leave that guy alone. So my vertex is negative, I just got through saying flip, and I wrote down -3. So flip that guy, leave the k value alone. So my vertex is 3, -6. Okay. All right, so now when I list out my transformations, I don't have a reflection, I don't have a stretch or shrink, and now because this is, remember back to the beginning of the notes, this is my horizontal stretch, the guy that's inside, that was that little x plus c piece, okay? You would think this means go to the left, correct? Okay, but remember our vertex form is x minus h, so it's backwards, it's the opposite of what you think it would be. Okay, so instead of thinking this goes left, this actually goes right. How much? It goes right by 3 because my vertex is 3, -6. All right, so that's the third possible transformation. And the fourth possible transformation is your k. That's your up and down translation. Okay, so here, since that's a -6, I'll leave it alone. That simply means I'm translating down 6. Okay, and this is all I need to see you guys write for these type of problems. I need the vertex, I need any of the possible 4 transformations, and then we got to graph it. Now to graph this, obviously need the vertex. So I'm going to go 1, 2, 3, down 1, 2, 3, 4, 5, 6, 3, -6. Now, how many points do you guys think we need, just like we talked about with circles, how many points do we need to draw a circle? How many points do you think we need to draw a halfway decent parabola? And the answer to that is 5, okay? So now there's a couple of ways to do this. One way would be to take some x values around 3 and plug it into this. You know, if I want to see where's the graph at 4, I can simply plug in 4. 4 minus 3 is 1. 1 squared is 1. Minus 6 is -5. So my output would be -5. But man, that is very cumbersome. The easier way to do it, guys, is to plug it into your calculator and use the table feature. Okay. So here's how you do this. You're going to go to press y equals right here. Y equals on your calculator. Type in our function. Y equals x minus 3, parentheses squared, and then minus 6. All right, and then I'm going to go second, make sure y'all can see that, second table or second graph. And this is going to give me my table of values. So here are all your inputs, here are all of your outputs. So what I do, guys, is I scroll until I see the vertex. So the vertex is at 3, -6. Okay, so I need to scroll down some. Okay, so there's my vertex at 3, -6. Now what I'm going to do, guys, I need 5 points. I need the vertex, and I need 2 points to the left and 2 points to the right to draw a halfway decent parabola, because a parabola, of course, is perfectly symmetrical. Now, in your table, what that means is I need 2 numbers above it and 2 numbers below it. So I'm not going to draw on my calculator, but I need these 5 numbers around the 3, -6. Okay, so I'm going to go to I'm going to create a little T-chart here. Make sure y'all can see this. All right, so maybe I'll put the calculator here. Okay, so let's make ourselves a little XY chart. Okay, so I always like to start with the vertex. That's kind of like my middle. That's the point of symmetry, right? So I've got 3, -6. I always like to put a box around that guy and put a little V right there. That's my vertex. I'm going to grab the 2 points above it. So I have 1, -2, and I have 2, -5. And I'm going to grab the 2 points below it. I have 4, -5, and 5, -2. Huh, that's interesting. I've got a -2 here and a -2 here. I've got a -5 here and a -5 here. Guys, it's supposed to be that way. Why? Because the symmetry, the axis of symmetry, is around the vertex, right? So these y values should be the same. So if these top 2 numbers don't match these bottom 2 numbers, that probably means you did something wrong, okay? So now that I have these 5 points, I can go to my graph and I can plot this. All right, so let's go 1, -2. I've got 2, -5, 4, -5, and 5, -2. All right, so hopefully the light bulb went off, and hopefully you guys saw that if you just plot these 2 points on the left, then it's just an axis, the axis of symmetry, this imaginary line going down through the vertex, that axis of symmetry is x equals 3. It's always going to be the x coordinate of the vertex, okay? So now I can draw my graph here. Let's connect those points. Put little arrows on the end of your graph just to notate that that goes on forever. Okay, and that's how you plot a quadratic when you are in vertex form. Okay, I'll do another one with you guys. Let's see here. I'm going to skip this. Y'all can do that one on your own. Let's go on over to the next page. Let's find this one. This is a good one. Number 4. Let's see if I can zoom in here a little bit. Okay, number 4. All right. So, first thing I need to do is I need to figure out what is my vertex. Okay. Now again, the negative here and the 1/4 have nothing to do with the vertex. This is my H and that's my K. But remember, I got to flip the sign in the parentheses and leave the other guy alone. So my vertex is going to be +5, -1. That's my vertex. All right, and then we need to figure out what are all of our transformations. So once again, I look from left to right. Do I have a negative sign there? Yes, I do. So that's one of my possible transformations. So that means I'm going to say y-axis reflection. Okay, but again, that really just means I'm flipping vertically. Okay, technically, it would be a reflection around the line y equals -1. Okay, but I just say y-axis reflection just to notate I'm flipping vertically up and down. Okay, all right. And the next thing I'm looking for is, do I have a stretch or a shrink? Okay, as I go from left to right, yes I do. I've got a 1/4 there. That's my A value. Now remember, the negative has no effect on the A value. The negative just means I have a reflection. So because it's 1/4, because that's between 0 and 1, that means I'm going to have a shrink. All right, listen to me. You cannot just say shrink. I need to know how much are you shrinking by. I'm shrinking by 1/4, or you can just say shrink 1/4. Don't just say stretch or say shrink. All right, the next thing I need to do is, do I have a horizontal shift? Yes, I do. All right, so I have x -5. So remember, I'm flipping that sign. So you would think that means move left, but it actually means the opposite. All right, so you can just say right 5. I'm taking my parent function, I'm shifting it right 5 because my vertex is right 5. All right, and the last transformation, this one I actually have all 4 transformations. I do have a vertical transformation, so I'll say, since that's negative, I'll say down 1. All right, now we need to plot it. So my vertex is 5, -1. Make sure you plot that correctly. Now let's stop for a minute. Is my graph going to open up? Is it going to look like this, or is it going to look like that? All right, it's going to open down, upside down. Why? Because I have a negative here. I have a reflection. All right, so I already know that my graph is going to open down this way. All right, so let's go ahead and get our points. I'm going to get some x and y values over here. So let's press y equals, and let's type in our function. I've got negative. Now you can type in 1/4. I'm going to type in 0.25. It's the same thing. Times x minus 5 squared, and then minus 1. All right, I'm going to go second table. I'm going to get a table of values. So remember, I need to scroll until I see 5, -1. Okay, there's 5, -1, and I'm going to put that in the center. So we got 5, -1. I like to put a box around it. That's just me personally. And I'm going to grab the 2 points above it and 2 points below it. Switch this since I'm right-handed. Okay, so I'll have 3, -2. I'll have 4, -1.25. Huh, that's interesting. Why do you think I have a decimal there? Because when I take my input and I plug it into all this stuff, I'm going to end up multiplying by 1/4. So yes, I would expect to see some decimals, 0.25, that kind of thing. Okay, so and then grab the 2 points below it. So I'm going to have 6, -1.25 and 7, -2. Once again, notice the -2 and the -2 match, the -1.5 and the -1.5. Or excuse me, -1.25, -1.25 match. That tells me I'm symmetrical. Okay, so let's go plot those points. So 5, -1, and then we've got 4, -1.25, so that's -1 and a little more. And then I've got 3, -2. Then I have 6, -1.25, a little bit more than -1, and then 7, -2. Again, feel free to pause these videos if things are going too fast. And now I'm going to connect my quadratic, but you'll notice that it's not quite as steep as the other ones. Okay, it's a little bit wider, right? Remember, so it opens up like a flower, like a tulip. It's a little bit wider because we have a shrink of less than 1. Okay, so I think that's all I need to do. Our axis of symmetry, by the way, axis of symmetry would be x equals the x coordinate of the vertex. So x equals 5 for axis of symmetry. AOS, axis of symmetry. Okay, so I think that's all I need to do for these problems. I think you guys should be able to figure out how to do the rest of them. Oh, one more thing I did want to say. How could I check and make sure that I've done this correctly? I plotted the points correctly. We can go to y equals and do what? Let's graph it. Let's graph it and make sure I didn't make a mistake. Does that graph look like that graph? Why, yes, it does. That takes 5-10 seconds, guys, just to check, make sure that you didn't make a mistake with your vertex and your parabola is supposed to be down here in the 4th quadrant and you made a mistake and now it's up here in the 2nd quadrant. Okay, so check your work. Okay, so y'all can do the rest of those. All right, so now we come to the fun part of the lesson, boys and girls. Wow, this is a little tricky. I'll admit, this is a little tricky. So make sure you are re-watching parts of this video if you need to, especially where I try to get my camera to refocus. Thank you. Okay, so I need to be in vertex form to be able to find the vertex and to find all the transformations. Well, guess what? I'm not in vertex form. I am in standard form, which is what I wrote at the beginning of the lesson. ax squared plus bx plus c equals 0. That's standard form. Y equals a times x minus h squared plus k. That is vertex form. This is an equation. Okay, if you want to write it as a function, you can actually write y equals ax squared plus bx plus c. Remember, guys, a function is just a relationship of two variables where one variable depends on the other. Okay, so if we're graphing stuff, we have a function. Okay, that y depends on x. All right, but you'll notice here I'm in this form, ax squared plus bx plus c. I've got a trinomial. I got to get it into this form. And the way to do that is I'm going to complete the square. Now you guys may be thinking, oh, we had our quadratic refresher. We just learned how to go from general form to standard form of a circle, or we actually had to complete the square twice. So hopefully you're thinking, oh, that's not that big of a deal. This is a little tricky. Okay, this is different, guys. This is completely different from what we just did a couple of days ago with circles. Okay, let me show you why. I'm going to have to complete the square. It says complete the square to reveal the vertex form of the quadratic, identify the vertex, describe all the transformations, and then graph. So basically, I've got to get it into the vertex form and then do what we just did up here. Okay, so stay with me. Here's what's going to happen. I'm going to change this to y. I'm going to have, actually, maybe I should do this down here. I got a little bit more room. Okay, I'm going to have y equals, now I got to complete the square. Now, here, listen to me very carefully. Normally, when I complete the square, I throw the constant to the other side of the equation. Okay, that's when I have an equation, when it's set equal to 0 or set equal to some number. I don't have that. I have a function. Y equals this stuff. Okay, so guys, you gotta remember, I am only completing the square on those first two terms, only on the x squared and the x piece. The ax squared term and the bx term. I'm not completing the square with the 9, okay? So watch what happens. I'm just going to copy these down. I'm going to have x squared minus 6x, and then here's our magical plus blank, just like we've been doing up until this point, okay? And then I'm going to have the plus 9. I just bring this down, okay? And now, when I complete the square, hopefully you guys are good at this. When I complete the square, it's always half of b squared, okay? I take half of this term, which is negative 6 divided by 2, and I'm going to square that. Negative 6 divided by 2, negative 3. Negative 3 squared is 9. Okay, I'll do this in different color like I usually do. I'm going to put that up here in this blank, so I have now completed the square. But check this out. I have a function. I don't have a 0 over here. This is different than what we've done with circles because everything that I do, guys, is on the right-hand side of the equation. Let me repeat that again. Everything we do with these problems is all happening on the right-hand side of the equation. Normally, if I put 9 bricks on the right, what do I have to do? I got to go back over here and put 9 bricks on the left to keep the seesaw balanced. I'm not doing that. Everything stays to the right. I can't emphasize that enough. Okay, so if I put 9 bricks on the right, I need to offset those bricks, right? I got a seesaw, perfectly balanced. I just put 9 bricks over here, a big old clump of bricks over here. If I want to keep the seesaw balanced, but I can't do anything over here on the left, I have to take off those 9 bricks, okay? So what I'm going to have to do is I'm going to have to come over here, and I'm going to have another blank. Okay, now normally we say when we complete the square, it's always going to be plus blank because I'm taking half of b and I'm squaring it. And when you square a number, you will always get a positive value. However, since everything's happening on the right-hand side, if I put 9 bricks on the right-hand side, I got to take off 9 bricks. So I have to offset that with a negative 9. Now, if your brain just short-circuited, stop the video, go back and rewatch. All I've done, guys, is I've added 9 here, and I took away 9 here. So they just cancel. The orange numbers cancel, and I'm right back to where I began. Mr. Manise, why in the world would you do something like that? Why would you add 9 bricks and then immediately take them off? Well, it's the whole purpose of completing the square. Okay, now I have taken these first two terms. Come on, blue. I've taken these first two terms that were not a perfect square. I've added this magical number out of thin air. I pulled it out of thin air, and now I have a perfect square trinomial that I can factor. Okay. Now, how does this guy factor? If you remember from the circles video, it factors as half of b. Half of b squared is how to complete the square, and then half of b is how it factors. So half of negative 6 is negative 3. So it's going to factor as, we got y equals, it's going to factor as x minus 3 quantity squared. Every time you factor this, it's always going to be a parentheses squared piece, okay? I take half of that number, x minus 3 squared. And then over here, I just combine my like terms, but now I've got 9 and negative 9, they just cancel each other out, which leaves me with plus 0, okay? So my official equation is y equals x minus 3 squared, okay? Now, let's go back up here and let's write down everything that we need. So now that we've got, now this turns into one of these problems, okay? So now what is the vertex here? The vertex is I flip that, so my vertex is flip that 3, comma, what is my k value? There's nothing there, so this is like plus 0. So my vertex is 3, comma 0. Okay, now for my transformations, I'll write these down up here. Do I have a negative for reflection? No, I don't. Do I have a stretch or a shrink? No, I don't. Do I have a horizontal shift? Yes, I do. Again, flip the sign. You think that's left 3, but it's actually right 3. Okay, and then I don't have a vertical shift. So in this case, I only have one transformation, and that's right 3. Okay, so now I'm ready to plot my graph. Okay, so my vertex is 3, comma 0. So let's go back to our calculator. Now here, guys, you could actually plug in the original equation if you wanted to, or you could plug in the vertex form. Okay, I'm actually going to plug in the standard form just so you guys can see that it's the same thing. So x squared minus 6x plus 9. I want to go second table. And our vertex is 3, comma 0. So let's scroll down to 3. There we go. There's 3, comma 0. Okay, and I'm going to grab the 2 points above it and the 2 points below. Okay, so I've got x, comma y. Okay, go about halfway down, 3, comma 0. That's my vertex. And then I've got 1, comma 4 and 2, comma 1. Grab the 2 points below it. 4, comma 1 and 5, comma 4. Okay, so I'm feeling pretty good about this because the 4's match, the 1's match, so I'm feeling pretty good that I've done this correctly. So let's go plot our vertex, 3, comma 0, and let's plot our other points. I've got 1, comma 4, I've got 2, comma 1, 4, comma 1, perfectly symmetrical, and 5, comma 4. All right, I can connect the dots. And there we have our quadratic. Okay. All right. Pretty tricky, guys. All right. So that's how you complete the square, though. The reason why we're learning this is I want to go from standard to vertex so I can immediately see what the vertex is and what all these transformations are. I don't know what the transformations are when I just look at the standard form. I have no idea. Okay. So make sure you need go back and rewatch that if you need to. I'm going to work a couple more here with you. I know this video is maybe a little bit longer than normal, but this is a little bit of a tricky lesson. Okay, so let's go on here over here to the back. All right, so now it's about to get real. It's about to get real. Okay. All right, let's take a look at number 13 again. The ones I'm not doing the video, this is what you guys need to finish for your assignment. Okay, so here I have 2x squared plus 24x plus 67. If you guys remember from quadratics, you cannot complete the square unless that guy in front of the x is a 1. Okay, it is not a 1. Okay, so I've got to do something about that. So just like I said earlier, okay, you are only completing the square, guys, on these first 2 terms. Okay, I don't care about the 67 right now. All right, so here's the way it's going to look. So I'm going to have a sheet over here. All right, so I'm going to come down here below. I'm going to have y equals, I've got to pull out the GCF. I can't even really say it's a GCF because I'm not pulling it out from all 3 terms. I'm only pulling out the GCF from the front 2 terms. So if I factor out a 2, that's going to leave me with x squared plus 12x. Now here's where I'm going. Oh, yeah, sorry, I can't see that. I'm going to factor out the 2. That's going to leave me with x squared plus 12x. Now here's where I'm ready to complete the square. Okay, the plus blank always goes after this bx term. And then I'm going to close the parentheses. Okay, the 67 doesn't get to play. All right, so pulling out the 2 from those 2 guys, and then I'm going to have the plus 67, and then I'm going to have another blank over here. Okay, now again, you guys are probably thinking, well, isn't it always going to be a plus blank? I can see how you think that, but you'll see in just a moment, sometimes it's not going to be a plus blank, and that's where it gets a little tricky. Okay, so now that I've factored out this 2, now you've got to turn on the blinders. Okay, now I'm going to complete the square on just this piece right here. Okay, so how do I complete the square? Half of b squared. Okay, so again, I'm just looking at this 12. 12 divided by 2 is 6, and 6 squared is 36. So I'm going to put this magical 36 that I pulled out of thin air, I'm going to throw it right in there. So that means to offset that, what do I have to put right there? Negative 36. That was me going over to my table to grab my bell. Ugh, Mr. Manice, why can't it be easier? It's not going to be a negative 36. Let me explain why. If I put in a negative 36 here, then this 36 and this 36, you would think they would offset, but guess what? I factored out a 2. When you complete the square, you're literally pulling a number out of thin air. But I didn't pull a 36 out of thin air. I pulled a 2 times 36 out of thin air. So guys, you got to remember, if you pull out a number on all these problems, if there's a number in front, when you pull that out, you have to go back and redistribute the factor that you pulled out times the number in the blank, and that's what you have to offset. I didn't put 36 bricks on the right-hand side of the equation. I put 2 times 36 bricks. That's 72 bricks, okay? So that means I have to offset that with a negative 72. Okay, take a deep breath. I know. Whoa, 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 whoa. What'd you just do? Let me say that one more time just to be clear. I pulled out a 2, so you've got to redistribute the 2 times 36, that's 72 that came out of thin air. I have to offset that with a negative 72, okay? All right, once again, why did I do that? I did that so that this piece could become a perfect square trinomial. All right, so now my function is, but I pulled out a 2, so here's where the 2 stays outside. 2 times, now how does the blue box factor? It factors as half of that number. Half of 12 is 6, so it's going to be x plus 6. This is always going to be a quantity squared every single time, quantity squared. 2 times x plus 6, then over here I just combine my like terms, that's minus 5. So, okay, so now we can see when I factored out this 2, that became what? That became my a value. So because I see this 2, that means I'm going to have a stretch. I'm stretching it vertically like a rubber band, stretching my quadratic, okay? So now I'm ready to go figure out the other stuff. So my vertex is going to be negative 6 comma negative 5, okay? And then let's go ahead and write down all of our transformations. Okay, so again, do I have a reflection? No, I do not. Do I have a stretch or shrink? Yes, I do. So here I'm going to say stretch by 2. Okay. Do I have a horizontal shift? Yes, I do. Flip that sign. It's the opposite of what you think, so that's going to be left 6. And then that's going to be what? That's going to be down 5. Okay. So for the sake of this video, so it's not so long, I'm going to let you guys plot that. But one thing I will tell you guys is, how do you know that you did this correctly? Okay, you can plot the original standard form and then plot your vertex form and see if they are the same. So I'll do that for you real quick just to show you. Okay, so let's plug this into our calculator. So y equals, I've got 2x squared plus 24x plus 67. Okay, all right, I'm going to graph that. Okay, that's that. I'm going to go back here, y equals, and now I'm going to plug in the vertex form, which should be that. So I've got y equals 2 parentheses x plus 6 quantity squared minus 5. Drum roll. Guess what? Nothing happened. Why? Because it plotted it right over the top. So that tells me, hey, I did it correctly. Now, if some of you guys with the newer calculators will do it in blue and red, you'll be able to see that they lay right on top of each other. Okay, so that makes me feel good. I know I've done this correctly. All right, last thing I need to do in this video, guys, last one, number 16. What is different about number 16? Ooh, I've got a negative in front. Okay, so let's complete the square. I'm going to have y equals, now remember, I'm only completing the square on those 2 pieces. Okay, but I've got to pull out that GCF, so I've got to factor out a negative 3, guys. It's got to be, not only does it have to be a 1, it's got to be a positive 1 before you complete the square. So I'm going to factor out this negative 3. That's going to leave me with x squared. Now again, a little tricky here, all these negatives. If I pull out a negative 3, I'm dividing negative 12x by negative 3. That's going to give me a positive 4x. If you're not sure, go back and redistribute real quick. Negative 3 times x squared, yep, negative 3x squared. Negative 3 times positive 4x, yep, negative 12x. Okay. All right, so now here comes the plus blank. All right, and then I've got the minus 18, and then I'm going to have another blank. I don't know if it's going to be positive or negative yet. All right, so now I'm going to complete the square. How do you do that? Half of b squared, half of b squared. I'll take half of that number. Okay, that's 2. 2 squared is 4. So I'll stick a 4 in that blank. And again, normally you would think, oh, I'll just offset that with a negative 4, but remember, you've got this guy right here. You've got this a value. You've got to go back and redistribute. You didn't pull a 4 out of nowhere. You pulled a negative 3 times 4 out of nowhere, which is a negative 12, which means you have to offset that with a positive 12. Okay, so this is one of the cases where all these other problems we're offsetting with negatives. Okay, but if there's a negative in front, you're actually going to have to offset that with a positive. So sometimes this second blank is a plus blank, sometimes it's a minus blank. It just depends on whether that front term is positive or negative. Okay, but now I can continue. So I have this right here. I can factor this. How do I factor this? Half of b. Half of b is how it factors. So I can't forget I've got this negative 3 out front. So I've got negative 3. Half of 4 is 2. So it's x plus 2 quantity squared. Combine my like terms, that gives me a negative 6. So my vertex is flip, leave alone, negative 2, comma, negative 6. Okay. Now what are my transformations? I have all 4 of them here. I have a negative. So I have a y-axis. I'll just abbreviate y-axis reflection. I do have a stretch here. Again, I'm just looking at the absolute value. That is a stretch by 3. I have a horizontal shift, left 2, and I have a vertical shift, down 6. Okay, a lot in this lesson, guys. Okay, once again, I can't emphasize this enough to go back and rewatch parts of the video, slow it down. Go to the YouTube video and click on 0.5 for the speed, and I'll be like, okay, where's the number? Slow it down as much as you need. All right. Let me know if you guys have any questions or concerns. Hope you guys enjoyed this video, and we will see you on the next one. Actually, you know what? I'm sorry, guys. I'm sorry. I'm sorry. I didn't finish. Okay, sorry about that. I got one more thing to show you. Sorry. I forgot this was on the back page. This is something I added a couple of years ago. This is super easy. It won't take very long. So, okay. So this says using the following mapping rules, write the equation in vertex form that represents the image of y equals x squared. Okay. This looks complicated. It's super easy. So what this is saying, guys, is it's saying I'm going to take a point. I'm going to take my vertex, x comma y, and then I'm going to do this to it, and then I'm going to do this to it. Okay, so if I take my x comma y, if I add 1 to it, okay, that basically means I'm taking my parabola and I'm adding plus 1. I'm taking all of my x values, every single one of them, and I'm adding 1. So everything, I'm adding 1 that way. Okay, every single point I'm adding 1. But if I'm adding 1, remember that it's x minus h, so it's the reverse. Okay, so if I want to write my equation of this parabola, I've got to have this as my horizontal shift, but it's reverse. And then this piece, what I'm saying is I'm adding 1 to the x's, and then what am I doing to the y's? I'm reflecting all of the y's because there's a negative there, and then I'm shrinking it by 1/2. Okay, so this is just another glorified fancy way of saying our transformations. So when I write my equation, it's going to look like this. A y equals, and I'm going to start with my reflection. I've got a reflection. I've got a shrink of 1/2. That's what I'm doing to the y's vertically. And then what am I doing to the x's? Okay, I'm adding 1 to it. Okay, so it's going to be x minus 1 parentheses squared. Because if I flip this, remember, if I flip this, this is right 1, remember? And that's what I'm doing. I'm adding 1 to all of my x's. Okay, so that's going to be the equation here. I'll do another one with you. Let's take a look at number 21 here. Okay, so what am I doing? I'm taking all of my x's and I'm subtracting 5. I'm taking my y's, I'm reflecting them. I'm shrinking them by 1/3, and then I'm shifting them down 7. So this one is going to be y equals, start with the y's. This little piece right here is just what goes in front. That's just basically your a. So I've got negative 1/3, parentheses, x, and then what I'll do here, change the sign, x plus 5, quantity squared, and then what am I doing? I'm shifting everything down 7. Okay, so this whole mapping business, guys, is just a fancy way of saying I'm taking a point and I'm doing something to it. I'm moving it, I'm shifting it, I'm rotating it, I'm reflecting it, I'm shrinking it, I'm stretching it. So we're just going from these mapping rules to our equation. Okay, so again, let's take 2, try again. So hopefully you guys enjoyed something from this video. Please let me know if you have any questions or concerns, and we'll see you on the next one.